These are the solutions for the unit circle mock exam. Use the graph below to find cosine of theta. Use the graph below to find sine of theta. Okay. Theta in this case is this red angle here. Okay. And they give us the coordinates of this point, which is the extension of this line coming out at angle theta. There is the x-coordinate, which is negative 8/15, which is this coordinate here. And then there is the y-coordinate, which is this coordinate here, which is going up like that. Okay. Let's figure out which is the cosine of theta. The way we do that is we look at these two coordinates. We look at this triangle. Okay. If we say that this red part here, let me draw the triangle in a different color. I'm going to draw the x-coordinate here as red. I'm going to draw the y-coordinate as green. And I'll draw the hypotenuse as black. This is the right triangle. We want to know what the cosine of theta is. Okay, remember, the cosine is going to be equal to the adjacent over the hypotenuse, because so, ka, toa. So the cosine is going to be equal to the adjacent over the hypotenuse. Okay, so let's figure out how long each of these measures is. The adjacent is the red line. The red line is the x-coordinate. Do you see how the x-coordinate is negative 8/15? So that means that this distance here is 8/15. Okay? Why do they say negative 8/15? Because it's going to the left. So when it goes to the left, it's negative 8/15. Okay? What about the length of this green part? It's going up. It is 15/17, right? Because the y-coordinate is 15/17. I'm going to write it right there. The x-coordinate is negative 8/15. I'm going to write it right there. Okay? So we've labeled our triangle with the two lengths that we know. Do we know the length of the hypotenuse? Well, actually we do. Look, this is a unit circle. So that means that any radius, including that one, is length 1. So the hypotenuse is length 1. Okay, now that we've labeled the adjacent, the opposite, and the hypotenuse, let's figure out what cosine of theta is. Okay, well, cosine of theta is equal to the adjacent over the hypotenuse. The adjacent is negative 8/15, right? And the hypotenuse is 1. So actually, the adjacent over the hypotenuse is negative 8/15, which happens to be the x-coordinate. So we've just discovered that the cosine of theta is equal to the x-coordinate of the point found by drawing an extension of the angle theta and hitting the x-axis, or hitting the unit circle at this point. So the cosine of theta is negative 8/15. And if you haven't realized it before, when you're on the unit circle, anytime you're trying to figure out the cosine or the sine of the angle theta, you can just look at the point where it intersects the unit circle, find the x and y coordinates, and those correspond to cosine of theta and sine of theta. The same thing is going to happen over here. We have a little triangle here, right? And I'm going to say that there's a red length here, and there's a green length here. And I'm going to draw the same triangle a little bit bigger down here. Red length here, green length here, okay? And then I'm going to draw the hypotenuse in black. How long is the hypotenuse? Well, it's the unit circle. So the hypotenuse is 1. How long is the red line? Well, the red line corresponds to the x-coordinate, which is negative 24/25. So the length here is negative 24/25. How can the length be negative? Well, they just say it's negative because it's extending to the left. Okay? What about the green length? How long is the green length? The green length is negative 8/25. Why is it negative 8/25 instead of positive 8/25? Because it's going down. When lengths go down in the unit circle, they are also negative. Okay? So in this case, it asks me for the sine of theta. Well, everybody knows that the sine of theta is the SO part of SOHCAHTOA. Sine is the opposite over the hypotenuse. Well, which one's the opposite and which one's the hypotenuse? Well, the angle of the reference triangle is that one there. So the opposite is the green part, and the hypotenuse, of course, is the black part. Okay? So if we were finding the sine of the angle, the sine of this angle, we want to have the opposite over the hypotenuse, which is going to be negative 8/25 divided by 1. So we're going to put as a sign as negative 8/25 because divided by 1 doesn't do anything, right? Now, negative 8/25, hey, that happens to be the y-coordinate of the point which intersects, which is the position where the angle line intersects with the unit circle. So the y-coordinate of the point on the unit circle turns out to be the sine value. Okay? So now we've kind of figured out that whenever you have the point of a line, or the coordinates of a point on the unit circle, that the first number is the cosine of theta, and the second number is the sine of theta. And what is theta? Theta is the angle which you start from the x-axis and turn around until you get to the line which intersects the unit circle. Okay? All right. Number 3, evaluate the expressions below without the use of a calculator. Actually, it's easier to do this first and then do this. So let's find the reference angle for each of these expressions, okay? Easiest thing to do, I think, is to draw a picture. So we draw a unit circle, and then we're going to find negative 210 degrees. Negative 210 degrees is, since it's negative, you start moving in this direction, right? So if we go all the way around, halfway around the circle, we've hit negative 180 degrees. Well, negative 210 degrees is about 30 degrees further than that, right? Which is about to there, okay? So then we need to figure out, okay, what is the reference angle for negative 210 degrees? We've just found negative 210 degrees. Now we're going to ask, what is the reference angle? Well, the reference angle is the angle that is formed when you draw a line from this point on the unit circle and make a vertical line until you hit the x-axis, okay? And when you do that, you have found the reference triangle, okay? This is a reference triangle, okay? The angle we have moved through is this angle. But what is the reference triangle which corresponds to this angle? Well, even though this angle is so big, the way we find our reference triangles is to draw a vertical line from the point until we hit the x-axis. Okay? So let's say that you have a reference angle, or let's say that you have an angle in this quadrant here, which is the first quadrant. Where is the reference angle here? Well, the reference angle here is very easy. It turns out to be the same as the angle. Okay? The reference triangle or the reference angle is just simply the angle between the x-axis and the angle itself. Okay, that was an easy one. Okay, what about in the quadrant 2? In quadrant 2, we're looking at this case here where the angle is in the second quadrant. Okay, and the way we form the angle is we draw the vertical line from this point to the x-axis, and so the reference triangle looks like that. What about in quadrant 4? In quadrant 4, we are in this quadrant here, and let's say that our angle is like that, okay? Where is the reference triangle here? The reference triangle here, we're going to draw a line, a vertical line from the point to the x-axis, and that forms our reference triangle. So that is our reference triangle for quadrant 4. What about quadrant 2, or quadrant 4? I'm sorry, this was quadrant 3. What about quadrant 4, which is over here? Quadrant 4, if we have a triangle here, the way we're going to find the reference triangle here is we take this point, we draw a vertical line until we get to the x-axis, and we draw our triangle between that point and the x-axis. So there is our reference triangle in the case of quadrant 4. Okay? So we've drawn out all possible cases, which is quadrant 1, 2, 3, 4. Okay? Now let's go back to our problem. Our first problem was to find the reference angle or the reference triangle for negative 210 degrees. Since we drew this triangle here, we can see that the reference angle for this triangle is 30 degrees past 180, right? So you could find that out by saying, okay, what is the difference between 210 degrees and 180 degrees, right? Because 210 degrees is 30 degrees past 180. The answer is 30, okay? So our reference triangle has a reference angle of 30 degrees, okay? You would not write negative 30 degrees. The reference angle is always between 0 and 90, okay? The reference triangles are angles we make because those are the angles that are easy to find the sine, cosine, and tangent for. Angles that are greater than 90 degrees, it's kind of difficult for us to wrap our heads around because we define sine, cosine, and tangent with a triangle that kind of looks like this, or maybe like this, or maybe like this, but in the end, these triangles range from 0 to 90 degrees, right? We didn't really define sine, cosine, tangent for angles that are negative or greater than 90 degrees. That gets weird, right? So the way we find sine, cosine, tangent for those triangles that are weird is we use this method here. We find the reference triangle first. We find the sine, cosine, tangent of the reference triangle. Then we figure out how we use the negative sign to alter the sine, cosine, tangent so they become the sine, cosine, tangent for weird angles like greater than 90 degrees or negative angles. Okay? So let's go to the next one. What about tangent of 135 degrees? Let's draw a picture of that. Okay? Tangent of 135 degrees is going to be, you're going to go from 0 to 135, which would put you about here. How far past 90 would you go? Well, 135 minus 90 is 45 degrees. So that would be straight diagonal, right? Now, if this is 135 degrees here, how much is left here? Well, you could do 180 minus 180 minus 135 degrees, which would be 45 degrees. It turns out that our reference triangle has an angle of 45 degrees. Okay? So this would be 45 degrees. All right. Next one, cosine of 240 degrees. Cosine of 240 degrees. Cosine of 240 degrees would put you around here. Okay? How far past 180 did you go? 240 minus 180 is 60 degrees. So we go to 180, which is about to here. And then we're going to go 60 degrees past that. 60 degrees past that is about like that, okay? So we've just drawn our reference triangle. Our reference triangle is a 60-degree reference triangle, okay? So we can see that the first one was in quadrant 2, right? The second one was in the first one was in quadrant 2. The second one was also in quadrant 2. And the third one was in quadrant 3. Okay? All right. Now, how do we use the reference angle to help us find the sine, cosine, and tangent without the calculator? Okay. When you have the sine of 30 degrees, okay, let's draw a picture of sine of 30 degrees. Sine of 30 degrees. If we have the sine of 30 degrees, we know that the sine of 30 degrees is going to be 0.5 divided by 1. Opposite over adjacent. Remember, when you have a 30, 60, 90 triangle, this side is 0.5. This side is 0.866. Some of you know this is square root of 3 over 2. Okay? And this is 0.5. Some of you know this is 1/2. Okay? So, when you find the sine of a 30-degree triangle, what you're going to do is you're going to take the opposite, which is 1/2, and you're going to divide it by the hypotenuse, which is 1. So the answer to sine of 30 degrees is simply 1/2 or 0.5, right? So we're going to put 0.5 here, and then we're going to check what the angle looks like when it's negative 210 degrees, right? And the picture we drew turned out to be this one, right? Okay, now we're going to remember what we learned from problem 1. A negative 210 degree angle, look at the coordinates for this. The coordinates for this would be negative, this would be a negative, and then the y coordinate would be positive. So the x coordinate would be negative because it's going left. The y coordinate would be positive because it's going up. Okay, so in this case, we're asking for the sine, right? And the sine is the y coordinate. And remember, the y coordinate is going up, so it's positive, right? So it's going to be positive 0.5. Okay, you're going to take the 0.5, which is the sine of 30 degrees from the reference angle, and then you're going to put positive 0.5 because it is going up. Okay? All right. Basically what we're doing is we're going to take this triangle, we're going to write out the coordinates here. You can think about the clock investigation we did, and the coordinates here are going to be minus 0.866 and 0.5, right? But since we want the sine of this angle, that means we want the y coordinate, and the y coordinate is 0.5, positive 0.5 no less, okay? All right. Let's look at the next one, which is tangent of 135 degrees. The tangent of 135 degrees is this drawing here, okay? What signs are we looking for cosine and sine here? Well, the cosine is going to be negative because it's going left, right? And the sine is going to be positive because it's going up, okay? Here we're looking for the tangent of 135 degrees. It turns out that the tangent of 135 degrees is related to the tangent of 45 degrees. So let's find out what the tangent is of 45 degrees. I just drew a 45-degree triangle here, and I wrote down the length of each side. We know that the 45-degree triangle has a hypotenuse of 1, like all triangles do inside the unit circle, and the length of each of the sides is 0.707, or square root of 2 over 2. So, how do we find the tangent of 45 degrees? Well, it's opposite over adjacent. Well, the opposite is 0.707. The adjacent is 0.707. So if you divide 0.707 by 0.707, guess what? You get 1. So the tangent of 45 degrees is 1. Okay? And so basically, the tangent of 135 degrees also has to be 1, but it might be negative 1. Let's find out if it's negative 1. If we draw the 45-degree triangle in the proper sector, which is in the sector 2 or the quadrant 2, we know that the opposite is positive and the adjacent is negative. If you take a positive number and divide by the negative number, you get a negative number. So it turns out that it's not positive 1, it's actually negative 1. Okay? All right, now let's look at cosine of 240. By the way, you could also do that by writing out the coordinates of this point. The coordinates of this point are going to be negative 0.707 comma 0.707, right? And if you take the tangent, basically what you're doing is you're taking the sine, which is 0.707, and dividing by the cosine, negative 0.707, and you get negative 1. Okay? Remember that tangent is equal to sine divided by cosine. Okay, that always works. All right, cosine of 240 degrees. Remember that the reference angle or the reference triangle for cosine of 240 degrees is 60 degrees. Okay, let's draw a 60-degree triangle here. If we draw a 30, 60, 90 triangle, we know that this side is going to be 1 because it's the hypotenuse. This side is going to be 0.5 because it's the short side, and the longer side is going to be 0.866. Some people know this as square root of 3 over 2. Okay? Now, in this case, we're looking for the cosine. So the cosine would be the adjacent over the hypotenuse, which would be 0.5 divided by 1. So we know that the cosine is going to be 0.5. The only thing we don't know is it's going to be positive 0.5 or negative 0.5. Okay, let's look at the 240-degree angle. The 240-degree angle is right here. Okay, the 240-degree angle is, looks like the x-coordinate is going to be negative because it's going to the left. The y-coordinate is going to be negative because it's going down. Okay? Now remember, the hypotenuse is always positive because it's diagonal. The hypotenuse has no sign. Okay? It's only the cosine and the sine that have negative and or positive. Okay? So in this case, we know that the adjacent is negative. We know the opposite is negative. In this case, we're looking at cosine, so we're worried about the adjacent. Well, in either case, they're both negative. Okay? It turns out that if you were going to write the coordinates for the 240-degree angle here, that the coordinates would be negative 0.5, negative 0.866, right? Both the x-coordinate and the y-coordinate are in the third quadrant. They're both negative, okay? So both the sine and the cosine are going to be negative. All right? Okay, so that was the first page.